2.3 Energy Utilization, Storage, and Distribution. So, today, energy use must be designed to be efficient in order to reduce the impact on the environment. Electrical energy must be generated for the increasing amount of electronics in the world, but coming up with solutions is challenging for engineers and designers. So, embodied energy is defined as the sum of all energy to create a product or service, and this is useful for calculations about success or effectiveness of a product regarding energy use. Distribution energy is national and international. It's defined as energy distributed very far distances in a highly centralized grid system. It's sent for all kinds of purposes, including domestic, commercial, and industrial use, and it's efficient and clean to generate electric power and thermal energy from one source to another. This saves the consumer money and reduces overall environmental impact. Microgeneration is a more small-scale generation of power by homes to meet individual needs, and it's an alternative to the grid system. So it has a lower negative impact on the environment and lower costs. However, the costs and resources to implement it initially are very high. So quantification and mitigation of carbon emissions. Quantification records carbon emissions and tracks carbon footprints of a production, and mitigation is human intervention to reduce these carbon emissions, and the reason for that is that these carbon emissions contribute to global warming, which is bad. So batteries, capacitors, and capacities. Batteries are devices that convert chemical energy into electrical energy, and because this is a relatively older technology, they've become more size and energy efficient, and there are many types of batteries to provide for a very wide variety of applications, and each of them have their own trade-offs. They all have different environmental impacts and efficiency. Capacitors temporarily store electrical energy, and capacity is the amount of charge able to be delivered.